All right, this is the stats probability review. So students were asked to share the number of hours they watched TV over the weekend. The results are as follows. Okay, they want us to make a dot plot. So we're going to make a dot plot. Let's draw a line here. Okay, we have 0 through 6. So we're going to be, let's do 0, 1, 2, 3, 4, 5, and 6. Okay, so I see 2 zeros. I see 1, 2, 2 ones. I see 1, 2, 3, 4, 5 twos. I see 1, 2, 3, 4, 5, 6, 7, 8 threes. 1, 2, 3, 5, 6, 7, 8. I see 1, 2, 3, 4, 5 fours. I see another 2 here, which I missed. I have 6 twos. Then I see 1, 2, 3 fives. And I see 1, 6. Okay, so there's my dot plot. This bottom here is hours. Watching TV. Okay, is the data distribution normal or skewed? This data looks pretty normal. So I would say it's normal, right? It's pretty symmetric, the left and the right half. Since it's normal, that means for the center, we are going to use the mean. And for the spread, we're going to use the standard deviation, right? Signified by the sigma symbol. Okay, and then now we need to find the mean, median, and mode. So what we're going to do is we're going to go to our calculator. Okay, let's see. We're going to add a list and spreadsheet, and then we're going to put the data in here. So I have 1, 5, 4, 6, 0, 2, 3, 4, 5, 2, 2, 1, 3, 2, 3, 5, 4, 3, 0, 2, 3, 2, 4, 3, 3, 3, 4. Okay, let's see. I had 27. 1, 2, 3, 4, 5, 6, 7, 8. 27. So we're good. Okay, and then we go to menu, statistics, stat calculations. Right, we're going to go to OK twice, and then it gives us all the stats we need here. Our mean is 2.92. Right, so where did our annotations go? So our mean is 2.92. Our median is 3. Our mode, the one that occurs the most, was 3. Our range is largest minus smallest. So max is 6, min is 0. So 6 minus 0 is 6. Our interquartile range is Q3 minus Q1, which is 2. And then our standard deviation right here is 1.46. Okay, so the two we care about the most here are going to be the mean and the standard deviation, because it is a a normal distribution. Normal distribution. All right. All right, next one. Okay, 11th graders took a biology test. Here are the results. Make a histogram. So we need to make a histogram here. Let's see. I have 44 to 100. So I'm going to do 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90, and then 91 to 100. And then for 41 to 50, there's two of them. Let's see, 5, 10, there we go. So this one, there's 2. And then I got 1, 2, 3. 3. 1, 2, 3, 4. 4. Looks like I'm getting a little close. Let's say right here is going to be 5. And right here will be 10. Okay, 71. 1, 2, 3, 4, 5. 81, 90. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11. So 11. And then 1, 2, 3, 4, 5, 6. Right, so this is going to be skewed, right? This graph is skewed to the left, pushed off to the left. So that means the center we want to use is the median. And the spread we want to use is the inner quartile range. Right, remember, if it's normal, you want to use the mean and the standard deviation. If it's skewed, you want to use the median and the inner quartile range. All right, let's put these in our calculator. So we're going to do a new spreadsheet, listen spreadsheet. Okay, let's put them in. We got 44, 48, 54, 56, 58, 63, 66, 67, 70, 71, 73, 76, 77, 79, 82, 82, 84, 84, 84, 85, 86, 86, 87, 88, 89, 91, 92, 94, 95, 98, and 100. Okay, that's 31. So 1, 2, 3, 4, 5, 6. $31. Good. Okay. Menu, stats, stat calculations, one variable statistics. Okay, twice. Wonderful. Okay, so our mean is going to be 77.7. Our median is 82. Our mode, I believe, was 86. We had, or 84. Did we have 3 84s? 3 84s. So I think our mode is 84. The data that occurred the most, 84. Range is largest minus smallest, so that was 100 minus 44, which is 56. Inner quartile range is going to be 88 minus 67, right? 88 minus 67, which is 21. Okay, and then standard deviation. $14.5. It's 14.5, right? So there's a lot of variation in this data. Yep. All right, and then the two we care about, right? Since it's skewed, the median and the inner quartile range. Inner quartile range, right? Which is 21. Okay, good. All right, last one. Okay, we're gonna make a box plot. So the number of wins for each NBA team are as follows. Find the 5-number summary. So let's use our calculator. Do a new spreadsheet. Okay, and then let's put our list in here. We got 64, 57, 57, 56, 51, 50, 50, 49, 49, 49, 48, 47, 47, 47, 47, 46, 46, 46, 41, 39, 36, 32, 31, 27, 25, 22, and 21, 21, 15, and 14. There's 30 NBA teams, so we're good. We can do menu, statistics, stat calculations, one variable, right? And then our 5-number summary, right, is min, max, Q1, Q3, and median. So let's write those down. Over here, a min is 14. The first quartile, Q1, is 31. The median is 46.5. Q3 is 49. And then the max is 64. So you're looking at this right here is the 5-number summary. All right, so make it the box plot. So let's go, we got to probably go from like 10. So let's start at 0, 10, 20, 30, 40, 50, 60, and then 70. Okay, so the min is 14, so maybe right here. The max is 64, so maybe right here. 31 looks like it's about here for the first quartile. 46.5 is probably here. And then 49 is probably here. So there is our box plot. Right? So again, this is 14. This is 31 here. This is 46.5, and then 49, and then 64, right? These are the numbers we're using here. All right, what is the range of win totals in the top 25%? So that's right here, which is 49 to 64. 49 wins to 64 wins. Okay, bottom 25%, so that'd be 14 to 31. This 25%, remember, all of these are 25%. 25%. 25%. And then 25%, right? The whiskers are each 25%, and the box has two 25% segments. So it's going to be 14 wins. So the bottom 25% of NBA teams have between 14 and 31 wins. Okay, middle 50%, that's the box part. So 31 to 49 wins. So 31 wins to 49 wins. So half the teams had between 31 and 39 wins. I'm sorry, 31 and 49 wins. Top 50% is going to be, so that's 46.5. So 47 to 64. 47 wins to 64 wins. And then the bottom 50% is going to be from 14 to 46.5. So 14 to 46. 14 wins to 46 wins, right? You can't have 46.5 wins. So we got to either go up or down. All right, and that's the box plot. Okay, next one. If you spin the wheel, what is the probability you get pink or even? So or means we're adding. So pink is 2 out of 8. Plus even 2, 4, 6, and 8. That's 4 out of 8. Okay, and then we have to think about, is there overlap, right? Can it be both pink and even? And since the pink are both odd, the answer to that is no. So we're not going to subtract anything. It's just 2 8s plus 4 8s. The probability of pink plus the probability of even is 6 out of 8, which is 3/4. Okay, if you spin the wheel, what is the probability you get pink or odd? So again, or, so pink is 2 out of 8. Odd is 4 out of 8. But this time you can get both pink and odd. In fact, both pink are odd. So 2 out of 8 of them are both pink and odd. So I need to subtract 2 out of 8. That's 6 minus 2 is 4 out of 8, which is 1/2. Okay, probability that you get a 7. Well, there's 8 of them. So that's 1 out of 8. Yellow and a 4. So are any of these both yellow and 4? No. So we're going to say 0. Yellow and 2. There's one of them that is both yellow and 2 out of 8 total. Pink or multiple of 2. So again, or we're adding. So the probability of pink is 2 out of 8. Plus the probability of a multiple of 2. Multiples of 2 would be 2, 4, 6, and 8. That's 4 out of 8. We need to subtract the overlap here because it can be pink. Oh no, it cannot be pink and a multiple of 2. None of the pink ones are multiples of 2. So there's nothing to subtract. So that's just 6 out of 8, which is 3/4. Yellow, 8 or yellow. So the probability of 8 is 1 out of 8. The probability of yellow is 2 out of 8. It can't be both 8 and yellow, so there's nothing to subtract. So our answer is 3 out of 8. Okay, blue or at least 5. So the probability of blue is 2 out of 8. Plus the probability that it's at least 5, meaning 5, 6, 7, or 8, is 4 out of 8. Okay, there is overlap on this one. It can be at least 5 and blue. So we need to subtract 1 out of 8 because one of them is both blue and at least 5. So it's going to give us 6 minus 1 is 5 out of 8. Okay, even or odd. So probability that's even is 4 out of 8. Probability that's odd is 4 out of 8. It can't be both even and odd, so you get 8 out of 8, which is a 1. Okay, and then even and odd, well, it can't be both even and odd, so that is 0. Next slide. you're determining if it's dependent or independent, right? It's independent if the second event is not influenced by the first event. It's dependent if the second event is influenced or dependent on the first event. So for the first one, you flip a coin and then roll a fair six-sided dice. The coin lands head up, and then the die shows a 1. So the flipping of the coin does not affect the die roll. So this one is independent, right? The flipping of the coin does not affect the dice roll. So independent. A bag of 8 red marbles and 4 blue marbles. You randomly pick a marble and then pick a second marble without returning the marbles. So you're not returning them to the bag. The first marble is red and the second is blue. So this one is dependent because the probability of picking the second one that's blue is going to be affected by the picking of the first marble, right? So if I pick one marble and it's red, the probability of that is 8 out of 12. And then I would multiply by the probability that the next one is blue is 4, but then I need to change this to an 11, right? Instead of a 12. So the picking of the first marble, it affected the second one, the second probability, right? So this probability depends on the first one. So this one's dependent. All right, a box of chocolates contains 5 milk chocolates, 5 dark chocolates, and 5 white chocolates. You randomly select and eat 3 chocolates. The first piece is milk chocolate, the second piece is dark chocolate, and the third is white chocolate. So this one is dependent, right? Because we're not putting them back, right? You're eating them and then they're gone. So the first one is going to be milk chocolate, right? Is 5 out of 15. Okay, and then it's going to be for dark, you have 5 dark chocolate out of 14 total, and then 5 white chocolate out of 13 total, right? So it's affecting the probability of the next one. So that's why it's dependent. A cooler contains 10 bottles of sports drinks, 4 lemon lime, and 3 orange, and 3 fruit punch. 3 times you randomly grab a bottle, and then you return the bottle to the cooler and mix them up. So since you are returning the bottles and then picking a new one after you return them, this is independent because the probabilities are going back to normal because you're returning them. You're replacing them. All right, good. Okay. All right, you select a card from a standard deck of cards, and then you shuffle 52. You return the card, and then select another one. Both times the card is a diamond. So the probability of getting a diamond is 13 out of 52. Okay, and then another diamond, since we're replacing the card, is then 13 out of 52. So if we go to my calculator, we got 13 out of 52 times 13 out of 52, which gives us 1/16, right? Or if you want to make it look nice and neat, you can use control divide, 13 out of 52. Times control divide, 13 out of 52. 1/16. Okay. Okay, a cooler contains 9 bottles of sports drinks, 4 lemon lime, 5 orange. You randomly grab a bottle and give it to your friend, then you randomly grab one for yourself. You and your friend got lemon lime. So the probability of getting lemon lime is 4 out of 9. Okay, once you grab one and give it to your friend, now there's 3 lemon limes left out of 8. So if we multiply those together, we get 12 out of 72, which is 6 out of, which is going to be 1/6, right? 12, 24, 48, 60, 72. Yep, perfect. Okay, there are 8 nickels in your pocket and 5 dimes. You randomly pick a coin out of your pocket, then return it to your pocket. Then you randomly pick another pocket. Both times the coin is a nickel. So the probability of giving a nickel on the first one is 8 out of 13. Since we are returning it to our pocket, replacing it, we still have 8 nickels now in our pocket out of 13. So that's 64 out of 169, which I don't think reduces. Okay, there are 8 boys and 6 girls in a class. That's 14 total. The teacher randomly selects one student to answer. Later, the teacher randomly selects a different student to answer the question. To another question. The first student is a boy. The second student is a girl. So the probability of getting a boy is 8 out of 14. Okay, the teacher is randomly selecting a different student. So since it's a different student, there's only 13 possibilities, right? And then there's going to be 6 girls that are available to choose from if they pick a girl, 6 out of 13. Okay, which gives us 48 out of 140, 154, 168, 182. Okay, which is going to be, let's see, 24 out of 91, which is probably a good answer. 91 might be a prime number. Is 91 a prime number? Maybe. All right, good. Okay, so now we got our two-way table and some conditional probability. All right, so on this one, let me see if that, yep. All right, we got our information here. So the first thing we want to do is add them up. So 80 plus 25 is going to give us a total of 105. So 105 people, teenagers, like snowmobiles. 55 do not like snowmobiles. 125 like skateboards, and then 35 do not like skateboards. Okay, what is the probability that a teenager likes skateboards but does not like snowmobiles? So we want likes skateboards but does not like snowmobiles. And that's out of a total. Let's see if we add up a total here. That's going to be 160 is our total. So out of 160 total students, 45 out of the total 160 like skateboards, but does not like snowmobiles. 45 out of 160. And again, we can reduce that if we want to. Okay, what is the probability that a teenager likes snowmobiles? Given that they like skateboards. So we're only looking at the people that like skateboards. We know they like skateboards. So of these people that like skateboards, what is the probability they like snowmobiles? That's 80 out of 125. Okay. Next one, what is the probability that they do not like snowmobiles given that they like skateboards? So again, we're looking at the category that they like skateboards. So of the people that like skateboards, how many does not like snowmobiles? That's going to be 45 out of 125. Okay, probability someone likes skateboards given that they do not like snowmobiles. So we're looking at the category of do not like snowmobiles. So of the people that don't like snowmobiles, what's the probability that they like skateboards? That looks like 45 out of 55. All right, next one. What's the probability someone likes skateboards and snowmobiles? So both skateboards and snowmobiles is going to be 80 out of a total of 160. half the people, right? That's 1/2. If we reduce it, 1/2 of people like both. Okay, likes skateboards or snowmobiles. Okay, or means we're adding. So what's the probability that they like skateboards? That's 125 out of 160. Plus the probability of like snowmobiles, that's 105 out of 160. All right, but we're double counting a lot of them, so we need to subtract the probability of both. So minus 80 out of 160, right? We add, then we need to subtract the probability of both. That's going to be, let's see, 230 minus 80 is 150 out of 160. So 160 of them, right? The other way to look at this is 10, right? 10 did not like either or, right? So you could have changed that to there, but 150 out of 160 liked both. All right. Then the last one I got here is a sock drawer contains 8 navy socks, 10 black socks, 6 brown socks. Joe picks one sock out, then another. So what is the probability Joe selects a navy sock and then a black sock, given that the first sock is navy? So we know he's picked out a navy sock. Okay. So there are 10 black socks left. And there are a total of 18 plus 6. So we have a total of 24 socks. Right, but he already picked one of them out and one was navy. So that means he has only 23 socks left. So it'd be 10 out of 23. All right, what is the probability Joe selects 2 navy socks, given that the first sock he selected was navy? So we know he picked a navy sock. So there's 23 total socks left. Since he picked one of the navy socks, there's only 7 navy socks left. So the probability he picks a second navy sock would be 7 out of 23. Okay, and that's it.